Good evening, everyone, and welcome to the, March 21st, 2022 Joint Governance Meeting where we'll be discussing sustainability. And we will move right into the little feedback there. We'll move right into the presentation in item 2 and 2.01. I will give that to you, Dr. Miller.
That's fine. Okay. Yeah, thanks. Dana, does Cliff Pasnell know he doesn't need to be on here? Okay. I mean, it's not that we don't appreciate bond counsel on these meetings, but
I just figured that out, and I will probably be leaving and coming back at 7.
okay. Yeah, there is a delay, and it can be disconcerting. Okay, so thank you. Sustainability is a key initiative. We have made progress. I would say that we have not made probably as much progress as we would have hoped at this point in the year, but that's the nature of priorities. And when our time is spent in certain areas and more than expected, it does have an impact on the operations of the district. And so we have a number of items that we are doing and implementing. We have 2 major things that we wanted to, again, touch on tonight, with the most significant being an update on the HVAC systems from Mr. Zimmerman. So again, our long-term goal, promote sustainability and reduce the environmental footprint. One of the key goals by the end of this school year is that we will finalize the Leadership Council. Again, we have board member representatives. You see Dr. Mihalik and Mr. Cassidy as a part of it. And we see this, again, as a really great opportunity to have students in an active leadership engaged role. So representative students from all 6 schools. We see, hopefully, 2 of them from each school on the council, which will allow them to have a buddy, somebody else in their school who's a part of it, and that those will then integrate into the school-based things that are happening. So we have, every building has its own identity, but then also we have this connection that we don't often see between schools when it comes to one of our initiatives. So that's the idea there. We also see a huge opportunity with our township. So as part of our communication to Township of Pine and Richland Township is to try to get connections. We know that's a part of their comprehensive and strategic planning. And so if we can find ways to connect and engage in that way, it really strengthens the partnership that we have with them. So again, by the end of this year, we want to have that group finalized and have held at least our first meeting. And what's nice about this group is it may be a group that we can get together in the summer as well to continue progress. So not everything needs to shut down in the summer. This is a perfect example of a group that could continue. Anything there? Okay. There's a little delay. Sean, if you want to just advance it. I see the cursor is like, okay. Okay. So here are some specific actions that are taking place. So there is progress this year. These are the areas of focus. The last 2 is where we wanted to spend our time this evening. I just mentioned the second to last bullet. And at the Finance Joint Governance meeting we had last week, as we talked about a number of things in long-term fiscal health, what we indicated as of last week is we're not recommending a tax increase for 22-23. However, we do see what is on the horizon. What's on the horizon in the next 3 to 5 years are significant costs, 2 or 3 times what we have invested into capital items, because not only, but primarily, we see HVAC replacement decisions that need to be made. So we've been working, Mr. Zimmerman has, with Tower Engineering. He's going to give an update on that. But this is something we really have to collectively understand. You know, in 2017, 2018, there was a decision, thoughtful, planned, to do a 1.97% tax increase, not because we needed it for operations, but because we needed it for for long-term capital investment. It was a revenue stream that we specifically talked about being able to move towards supporting capital expenses. It has allowed us, since that time, to do annual projects between $2 and $3.5 million each year, and have almost all of that addressed through the operating budget, through the annual operating budget. We have not needed to incur additional debt. We have not needed to spend down fund balance. So our overall financial health has increased over that period of time. And part of the question is, that we collectively face is, when or is there a next time to consider a similar type decision? And because again, there are choices. We can incur additional debt. We can spend down fund balance. We could pull the lever of a small increase, or any combination of those things are part of what can be considered. When Jeff starts talking about HVAC, they range in systems, and those systems range in costs, and they have elements and components that need to be a part of a decision-making process, and they certainly fit in with sustainability. So next slide, Sean. Okay, so Jeff's going to take it from here.
All right, good evening, everybody. I'm going to be going through how we're incorporating our sustainability initiative into a current project, which is our HVAC replacement strategy. As you're seeing in the past board meetings, we approved some HVAC upgrades to the RTUs, the rooftop units at 3 different elementary schools. That's not part of the strategy, but it was part of our capital funding plan, and I'll point that out when we get to it. But it also has a lot of the same elements that we're going to discuss here. All right, next slide, please. All right, so as part of tonight's agenda, we're going to go through, and I'll just explain briefly the asset lifecycle system in our capital funding plan, and how we're kind of already looking at large expenditures in our future. We'll talk about what our HVAC replacement strategy is, what components that we have in there, and then I'll use the middle school as an example to show how we're implementing that into our decision-making process. And then we'll just conclude it with next steps and any questions that you might have. Okay. Before I get started, I just want to say that I'm going to try to make this as simple as possible to understand. I don't want to, if I start talking above anyone's level of HVAC, just let me know. Because, right. Horizontal unit ventilator. So I'm a civil engineer. I'm not a mechanical engineer. Normally mechanical engineers are the HVAC guys that you would see. And also a lot of electrical engineers do a lot of this processing. I've been in facilities on the civilian side since 2001 when I got out of the military. So I have a lot of background in HVAC, but I'm not a mechanical engineer. And that's when we talk about why we're having outside engineers help us, that's a lot of the reason why. So just to explain what the asset life cycle is that wheel over on the left-hand side. Right now, we're in the planning side of it. As soon as we get into what we need and get an engineering design done, we'll go into a bid phase, and we'll go into an acquisition phase. And then the operation and maintenance side is kind of where we're at now with all our buildings. Our buildings, a lot of them you'll see, especially off to the right there in our in the graph that's kind of busy there. There's the second column over, and the first one in blue on the left there says equipment age. A lot of our schools have really old equipment. When you start thinking about HVAC equipment, like the unit at your house, 15 to 20 years is probably life for that. The rooftop units we have at the school, 20 to 25 years is about the expected life. For a boiler, so we use hot water for our heating. The boiler is the main component of that. That big boiler, or most of the time we have 2 of them in the basement boiler room. They last about 30 years. So that's what we're all talking about with the asset life cycle. Right now with a lot of our schools, we're in the phase where we're getting to the end of life and we need to start looking again at how we're going to resource our buildings. So I explained to the right there, that graph on the top right corner is something that we showed the board in 2019. And that was our best guess at the time based on the capital funding plan and the age of equipment where we thought that major replacements were going to take place. And as you can see there, Wexford and Hants have a small budget of $150,000 kind of in the year groups that we're discussing, like the current year group, 2021-22. Those are being addressed with the HVAC project going on right now with the rooftop units. So as part of that ARP ESSER money, we were able to directly take care of those two right there. And we're also working on Richland. So you can see Richland was a couple more years out, but we're going to use that $800,000 to take a big piece of those big projects out of the way. But what you can really see there is the middle school.
So that's the 800,000 of the 1.1-ish.
Right.
That was the biggest chunk of money from the ARP ESSER.
Okay. And as you can see there, the biggest large project that we have is the middle school, and that was identified in the capital funding plan, the original capital funding plan done by Mr. Zhang and Mrs. Kirk. So we're looking at a project we think is going to be in the range of between $3 and $5 million, depending on what options we choose, what level of sophistication we choose, or what kind of technologies that we pick. And then I'll just explain the graph on the bottom there. That is how the two top graphs kind of fit together. The capital funding plan has the yellow and orange graph with everything put together. With all of the projects that we have going along, we think we're going to have a big budget spike year come up in like 2024. And right now we're looking to smooth that graph to make our expenditures more level loaded and more sustainable, and we'll get into that as we go along. Any questions so far? Okay, next slide, please.
Sorry, but for Eden Hall, have we made a significant investment in the HVAC
We have not.
previously? It just really astonishes me, right? So the idea, sometimes building new doesn't seem, you're like, well, we could rehab this building. I mean, what a tremendous difference, right? You build new, and over the course of what will extend to 20 years, your investment is projected only $750.
Right.
Look what we're spending on 3 elementaries that contain the same student population because of the age, I'm sure, right?
And that brings up the question, like if you ever wanted to do a full refresh or build a new school, right now we're going to bite off a big group, a big year group of 20 years. So, whatever we decide now has long-lasting impacts.
That's why I bring it up. Yeah, thank you.
Well, just to follow up on that, has there been any looking at the building envelopes of the older buildings? So sometimes before you'll do this type of equipment update, you'll look to see if there are leaks and places that you can plug up that kind of reduce the load and maybe reduce the cost. But I don't know to what extent any of that's been done, but yeah.
Yeah, so that's part of, so the ARP ESSER project that we just rolled out, that was part of it. So when we started to look at what the replacements were going to be, we started out with, let's just figure out what like for like looks like, and let's go back after that and determine what the actual if the needs of the building have changed over the last 20 years. Some of those classrooms have turned into small conference rooms, so they really don't have the load that they used to. In some other areas, Wexford Elementary, a lot more students than they had 20 years ago as well. So that's part of the whole design process with tower engineering. Okay, next slide, please. All right, so segueing into the tower engineering portion of it. So we've asked tower engineering to come out and give us some professional assessments of our buildings. In 2019, the middle school and Richland Elementary were finished. And we just recently got approval for Hants and Wexford. Those will be done this spring and the summer so that we can start addressing those, the planning cycle in the fall this year is what we think. Part of the strategy that includes Tower Engineering is because they have a lot of HVAC background. They have a lot of mechanical engineers on staff and electrical engineers. They're able to go through, they've gone through the middle school in Richland and evaluated every piece of the system. So the boiler, so Richland Elementary has a boiler. It also has a chiller for all the cooling. So the boiler does the heating loop, the chiller does the cooling loop. And then within each classroom, we have the unit ventilator, which pulls either the heat or the cooling through that loop for the room. So Tower has looked through each of those schools based on the age of the unit and the design life. They've made condition assessments and given us how much life they think is left on each piece of equipment. And those are some pretty powerful assessments that they give us. Those assessments are not, they're not cheap. They're $5,000 each, but the level of engineering that goes into those we feel is really worth it for our decision-making process. And I'd say one thing that makes it even more difficult, so you have the equipment itself, you have, they make suggestions based on what it would take to install new equipment. They also look at the roof and the structure that holds the roof up to see if we can hold new equipment in different types. And they also look at controls, and the controls portion is a very difficult portion where all the units are tied together so that we can use the thermostats on the walls, we can use the automated system through a computer and take care of everything right through our controls. Our controls are really old in a lot of the schools that we have now, so this is a great time to upgrade those as well. Next slide, please. Okay, so after we receive these assessments, we're going through right now and evaluating alternatives. And when we look at alternatives, we're looking at what our decision criteria are going to be. The orange balls there are just some things that we're thinking about as we're going through each design and each alternative at each location. So like at the middle school, I'll show you in a couple slides down the road, how we're looking at some big things. So constructability and feasibility, there is just some of the alternatives that we were looking at for the middle school where it's just not going to work. The middle school has a low roof deck on it. The room between the top of the finished ceiling and the bottom of the roof deck doesn't really support big duct work. We also would run into issues where if we want to put things that are heavy up on the roof, we'd have to add structural steel. And so all of those things are coming in. So constructability is one of the big ones. But also we're looking at what our needs are. And our needs are right now are humidity control and indoor air quality. We want to go ahead and upgrade. If we put any new units in any of our schools, we want to make sure that they support MERV 13 so that we can get, pick up virus level particles out of the air. We want to make sure that we're moving ahead. So humidity control is big for us as well, trying to get all the allergens out of the air. So IAQ is a big one for us. So you can see just all the little things that we're looking at. And also, as we'll see later, first cost is a big one. So you're looking at first cost versus operation costs versus kind of a wow factor. So we have to, as a group, decide whether we want to be the wow factor group or we want to do things that just make economic and engineering sense, or if we want to pick something that kind of leads the industry in what we pick, and we'll explain that a little bit later. So this is the process that we're at right now. We're using the designs, we're meeting back with Tower Engineering, and we'll be going through and determining our criteria and then providing a weighting system for each of them because they're not all equal. All right, next slide, please. All right, so I'll kind of go slow during this slide because it's kind of our options, and it might be kind of difficult for people who have never really looked at different types of HVAC systems. So I just put them in different colors there. So right now we have a univent system. So I described it before that the heating at the middle school is done through a boiler system. So the boiler loop, the hot water goes out of the boiler, it goes through a univent. The univent has a system that pulls out, it has a coil, and when hot water goes through the coil, the fan blows the hot water out and it conditions the room with heat. So that's how we heat at the middle school. If we would have a chiller like we do here at the high school or at Richland Elementary or Hance Elementary, it would do the same thing for cooling. The chiller would push the cold water through the system and it would come out through the univent. But at the middle school, we have a different type of system. The middle school and Wexford are different, where cooling is done within the unit itself. It's kind of like a unit that you would see at a hotel room when you're on vacation. It has a little compressor inside, little condenser. When you turn it on, it makes a lot of noise and then cold air comes out. So that's how all the rooms in the middle school are cooled right now, and that's the bottom left right there. Rooftop units, as we kind of talked about in our ARP ESSER project, that's what the rooftop units look like. They're a package unit. They have the cooling, but it's up above the roof deck, so you really don't hear it when it kicks on. But it also has capability for a boiler loop through it, or it could have a gas burner in it, so it's one of the two. The VAV package unit is the big unit on the bottom. That is what we have right now at Eden Hall, Upper Elementary. Those units are awesome. They're really big. You can see they weigh a lot. So Eden Hall, when it was designed to hold that level of load on the roof. Those units provide variable air, so it kind of goes through ductwork. It's quiet. It's efficient. We really like those. I just don't know if it'll work for the middle school. And then geothermal. That's where I was talking about if you wanted to pick something on the expensive side that's more of the more efficient side, the one that a lot of people who are really into efficiency and sustainability like to push geothermal. It's expensive. We would have to drill down into the earth. They put these little wells that go down in. You put the coil down in, and it really takes the place of the big boiler. It kind of takes, the ground temperature is about 55 degrees, so it kind of takes the edge off, the heat exchange. You'd still have some kind of a heat pump and you'd have some kind of a cooling system, but it wouldn't need to be as big because you're using the earth to kind of help out. But those are very expensive. And then on the other side, there's other technology that we'll be looking at as well. So this is just kind of the options that we have available to us. So on the far left is what we currently have. And there is another option there called the vertical univent. So the one you're seeing there is a horizontal. A vertical is kind of a mix. And as it states, vertical just means it stands up. So the way that the air passes through the coil, especially in cooling mode on that, the air blows right over the coil in a short distance, so it doesn't really have a long time to cool the air and dehumidify it. The unit has to run constantly to dehumidify. We're thinking with our engineer expertise from Tower, they said that the vertical unit brings the air in from the bottom. It passes the coil the whole way up. It's discharged through the top, through flexi duct, and then can come down in different areas of the room. It just dehumidifies better. So that we're looking at that as one of our prime ways that we think we can install something that makes sense, has a good efficiency rating, and will meet our requirements. Next slide, please. Any questions so far on that? All right, and I kind of explained this in the last slide as well. Right now, the black bubble for existing univents, that's where we are for efficiency and cost. If we just replace like with like, we would be in that level right there. The engineers are telling us that the bump up between our old equipment and what a horizontal univent or a vertical univent would be about a 10% increase in efficiency right now, just because of 20 years of upgrades in the equipment. And then the VAV package units are a little bit more efficient, and geothermal is more efficient, but you can see the price goes way up. So when we're looking at pricing, the $2 million mark is kind of right around the horizontal unit vents. So the middle school project would be right in the, it can start out at 2 million and go up to about 5. That's where we think the range was as of last year before everything got crazy with material availability as well.
Just trying to wrap my head around this because this is definitely not my area of expertise, but
Yep.
last summer we replaced our house. So, when you're talking about some of the more efficient ones costing more, in the long run though, that efficiency will bring down yearly or monthly or whatever cost,
Right.
correct? So it's a
So
little
that's
more
what we're going to look
upfront.
at.
Okay.
We're going to put together like a cash flows over the years just to see what the net present value is of each different alternative. That's what we're going to look at when we get it up. And so we're looking at environmental costs as well. So any incentives, so I don't really know if there's big incentives for geothermal right now, but we'll consider all those as well.
And part of that equation, I'm assuming, is also going to be life expectancy. I don't know if some of those
Right.
more efficient, sometimes when you're pushing equipment harder, the life expectancy goes down and or maintenance goes up. So all that will be included in that.
It will. So
Okay.
we'll do a graph of just the lifespan of it and the anticipated costs, so we can kind of make sure that we're balancing everything properly.
Is there any intention to do any sort of environmental evaluation in terms of like total energy consumed for each of the different options over, a life cycle? Because that might be useful to see as well, too.
Yeah, so I think we'll do that as part of the operating costs. So operating costs will have a maintenance component to that and an energy usage as well. All right, next slide, please. Okay. So as I've kind of explained earlier, this is what we have at the middle school currently. So on the right is just like it's a site plan for the middle school. It's a typical classroom where the univent is in the middle of the wall, on the outside wall, and normally with a bank of windows above it. So there's like four to six windows in each room with the univent under it. It's built into the cabinetry, as you can kind of see there. So those are some issues that we're looking at, as well as just the engineering itself of the unit. We're looking at how it fits into the current classroom, how much of a disruption it's going to be for each different alternative. And as I stated on the slide there, there's 45 univents in the middle school. Each of those is about, if we just replace it like with like, in the $30,000 range. Rooftop package units, 24 each that are on the roof. That's another $500,000. So that's where we get to the $2 million starting point right there.
Are the rooftop units, because all the heat exchange is happening outside in the compressor and so on, that would make it quieter, but there's still going to be a blower or a fan in each room, right? Is that how that works?
So I'm sorry. So the rooftop package units, the 24 that are in the middle school, there's 2 in each gym. There's 1 above the main office. There's some in like the nurses' offices. They're all spread out in more common areas, in some hallways, auditorium. So those rooftop package units really don't supply any heating or cooling to individual classrooms. So each one of those 45 unit ventilators really corresponds to a classroom. Some classrooms have more than one. They might be ceiling mounted, but they pretty much have the same kind of operation though. And on the slide, the DX cooling is what I kind of described earlier, where it's self-contained within the unit, which it's the loudest part of like in the wintertime, you'll have the fan kick on to blow the heat, but in the summertime or in the spring and in the fall, when the kids are in, the DX cooling is kind of loud because it's a compressor within the unit itself. All right, next slide, please.
Are there improvements with that, Jeff, in terms of, right now, and I guess some of ours are older, so that causes some of the additional noise, but improvements for sound with these unit ventilators?
Yep, so if we chose an option that was like for like, only, upgraded equipment based on the year we're in, we got some input from Tower that said that the efficiency rating, like when you buy a new refrigerator or something, there's an efficiency rating on it. They're going up from like 8.5 to about 11.5. I don't really know what that means in terms of percentage, but they have gone up quite a few efficiency ratio points in that, and they do have better sound deadening. A lot of our equipment that we have at Wexford and the middle school, the foam is deteriorated. It's so old that the foam's kind of deteriorating off and kind of doesn't really have that sound deadening it used to. Plus, while the technicians are working on them, we'll replace new bearings, new fans in, and when we do, we get some extra noise with that. So we think that the new units will be a lot more quiet, and the vertical univentilators are a lot more quiet because we can discharge the air throughout the room rather than just localized to the unit as the students that are sitting closest to it. So when we looked at the middle school, according to what we've gotten back from Tower before, we're able to, even though we don't have the design back from, we do have the one for the middle school. We're evaluating it. Heating mode works pretty good. Cooling mode, it's really unreliable at this point. So we know that we're going to replace it, so I'm not going to like really dwell on that. But we're looking for a system that can operate in on like a 95-degree day. So that's what we're designing it for. 95-degree day means that actual intake of air at 90, we can cool it down and make the room comfortable. Right now, we can't get there. We had a lot of downtime. We had a really hot couple of weeks in May last year that caused a lot of our units to go down at the middle school and at Wexford. And we ended up doing a lot of repairs throughout the summer. It happened again in August. We had one really hot week, and about 8 units at the middle school went down that week. So we really need to get this done. I don't think we can do a wait and see approach where we keep doing repairs. I think we need to do something. And repair costs really isn't the big thing for us. It's downtime right now and part availability. So the units are old. It's hard to get the exact repair parts we need in a timely fashion. And then, like I said earlier, controls is a big one. We don't have a central interface at the middle school. I can't log in right now and see what every room's doing at the middle school. I can do that at Eden Hall. I can do that at the high school. So it makes it hard to figure out what's broken before we get a call from a teacher. So at the middle school, the first call we get is normally a teacher or a principal complaining about something. We can come in at 5 o'clock in the morning, have one of the technicians dial into any one of the other schools and know what's happening before kids show up. And then ventilation and filtration. So this has a lot to do with sustainability here as well. We're upgrading the amount of ventilation and filtration we have just to help out with COVID-19. Our units currently are only MERV 8 or MERV 9 compatible, and MERV 13 is the first level of filtration that takes out something as small as a virus particle. And then also, I kind of mentioned with our current units, the supply and return is really, the supply is right under the unit and the return is the top. So the kids that sit closest to the univents, they're getting most of that air right on them, or, a lot right in their localized areas. So if we can upgrade it to something, we're looking to spread that air out, make it more comfortable in the whole space. All right, next slide, please. All right, so these are some of the limitations and considerations I kind of brought up throughout the presentation. So the existing univentilators, like I said, they're along that the outside wall, they're underneath the windows, and the cabinetry is built around them. That's some of the considerations we're going to have to make whenever we decide what option to go with. Some schools that have upgraded, like what we're doing, have either turned that univentilator, just abandon it in place and turn it into like a bookshelf, or sometimes they pull them out completely and change the whole room itself. But so that's one thing we'll have to look at. Like I mentioned before, the space between the roof deck, the bottom of the roof deck, and the top of the finished ceiling really doesn't support the VAV option. The VAV option is made for some buildings just like Eden Hall, where we can put 10 or 15 of those on the whole school. We can share ductwork for a whole wing, and then the ductwork just goes down and feeds all the rooms. To do that, you need a lot of space for ductwork. We just don't have that here. If we tried to do it at the middle school, we'd have to scale the units down small enough that where it could feed like 2 rooms, which is kind of inefficient. Repairing existing equipment doesn't address our concerns for dehumidification. That's one of our biggest things we're looking at. And the geothermal option it's complex. We'll have to assess that one more, but it's not something that, you know, we're gonna thoroughly look at each alternative and then bring that presentation back to you. And then the second to bottom one is the cost. So as I brought up in the first couple slides, we have that big cost impact hitting us in the next, it feels like the next 5 to 7 years. We're going to try to make sure that we can get things done that make sense. We'll repair when we need to repair. We can delay when we need to delay, but we'll bring that up to you so you guys can make informed decisions about that. And we're still evaluating all options. So next slide.
Just to jump in there really quick, in the capital funding plan as you last saw it, the middle school project I have estimated for the 23-24 school year, and I picked $4 million. So I just kind of plucked a number out of the range, tried to go on the upper end, knowing that even if we pick something like the vertical units, that obviously we would need some costs in there to try and fix up those classrooms as well, especially if we were pulling out the horizontal units. I did not budget for the full $5 million end of the range, but like I said, I'm kind of closer to it. So currently right now we're at the $4 million mark.
All right, so based on the conversation, you know, we just had in the presentation and what we've worked internally with tower engineering, we kind of have some initial ideas on what we think could work well for us. We haven't, you know, we're not solely looking at one option, but this is the vertical univentilator and just an example of how it might work in a room. So the far picture on the left is a univentilator, and it kind of looks like just a piece of the wall right there. You can see the return duct is along the floor, that grate along the floor, that grating. And then you don't see where the air comes out because it goes up and over the ceiling and then gets spread out throughout the ceiling tiles through supply ducts like we'd have in this room here. The middle diagram there is actually a floor plan from South Fayette High School. And South Fayette went with the vertical univentilator. In that diagram, it's in the top right corner. And you can see the ductwork comes out along the window line and then branches down. But that would be above the ceiling, you wouldn't see that. So that's kind of an example of how it would fit in a room. And then the last picture on the right is a picture from our middle school. And you can see like the tall wardrobe closet on the far left there is kind of like where that vertical unit ventilator would be. So we could make that work in that space with some minor alterations to the cabinetry work. So it could work there. So that's kind of the process that we're using. We haven't just determined one path yet, so we're evaluating everything, but that's kind of our thought process and how we're looking to make sure that everything works together. The reason that this ductwork works is because we could use smaller ductwork because it's one unit. It doesn't have to support like 3-foot wide ductwork or anything like that. It's just small stuff, and we think that could work in this capacity. Any questions on this slide? All right, next slide, please. Okay, so the next steps, we've kind of talked to you about this before. With this spring and summer, we're going to complete the assessments for the 2 other elementary schools. We're not planning right now to do an assessment for Eden Hall because that equipment is still halfway through its life cycle. We can do that later, but that school's got really good equipment. It's doing very well. It's easier to maintain, and it's doing really well. So we're looking at, for the summer and fall of this year, where we're going to keep this evaluation process going. For the middle school, we hope to choose something here by the fall, establish a bid process so that we can bid the middle school January timeframe, end of December, January timeframe, so that we're ready for some construction in the summer of '23. This is a big project that would pretty much require a lot of the work to be done during the summer. So it's just tough, because if you miss 1 year, you're waiting a whole another year to do it, unless we decide to do something that we have to coordinate within the school itself. But the summer lends itself to be the best time for this. All right, so I think that's my last slide.
So
Any
thoughts?
questions? Concerns?
No, it's thoughtful and well laid out. Thanks, comprehensive.
Just the one, I'm making this assumption based on everything that I'm looking at,
Yep.
is it does not seem like it will be feasible to standardize across all schools simply because of the way the schools are built.
That's correct.
I was just looking for an economy of scale of, somebody that's doing maintenance here has the same equipment. That's not going to be possible for us.
Some of the high-end options aren't able to do that. We can probably do the vertical unit ventilator at every school.
But that would then be less efficient at some of
Right.
the other schools, right? So,
Right.
yeah, okay, all right.
Yep, so we'll make every school, that's why we'd like to have all the assessments done right now, so that we can kind of game plan that and talk in the fall, and then, like you said, try to get some efficiencies or economy of scales.
Okay, thank you.
Yep.
Any other comments? So the need, we feel, is crystal clear. If anything, we're hanging on and hanging on by a thread. So the summer of '23 seems critical. This is a huge question of future focused finance. Huge. The tax increases are not popular. Spending fund balance is not popular. Incurring additional debt when we've had a long-term strategy to try to reduce debt as a percentage of overall budget is not ideal. A combination may be something to think about. We're talking about as much money in these 4 HVAC projects as probably 15 to 20 years of technology devices and textbooks and resources to support our classrooms. I mean, it's a big deal that not a lot of people will pay attention to necessarily. This will be one of the most critical financial decisions we make collectively as a district and as a board, and we're going to be making them within the next, 6 months to a couple of years. And, ideally, everybody votes their independent decision. So a question that a board member might ask is, well, how do I know we can do this if I don't know we're efficient or effective there? And we have been focused on efficiency and effectiveness of our staffing for years. So we are as lean to deliver high-quality services through our staff as you can find. We benchmark well. We're extremely transparent in that process. Then we go to debt management. Then we go to transportation costs. I mean, we're knocking out the big things that we pay for. We have done the due diligence over the years to build really mature, effective processes to know that we're there. One of the questions that came up a number of years ago now was, how can we be more accurate in revenue projection to understand then, if you will, less conservative, in order to ensure that we know that when and if we pull a lever that has not been pulled very often in the last decade, once or twice if we go back to 2012, 13-ish timeframe. So this is huge, and this is something that is best done with us on the same page. I mean, that's not to say that people can't do whatever they want to do, but these are real things, and I would not want this decision to be anything other than like we're trying to walk there hand in hand. And if anybody has an idea that we don't know about, we need to hear that sooner rather than later so we can get there. Matt?
Yeah, thanks. I just thought of something while you were talking. So I do a lot of work with people in the School of Architecture at CMU and have sat on a couple of dissertation committees. There's a lot of evidence about the benefits of fresh air being brought into buildings where students work and also where, teachers, other staff work. So I don't know the extent to which Tower will be able to provide you with some sort of assessment of how much fresh air is being brought in and how that's dispersed. The economic benefits of having that are clear. They've studied that, and it's very impactful. It reduced time off of work, more productivity, better mood, attitude, all those sorts of things that I think could be beneficial. So while we're doing this, if there's a chance we can take a look at that, that would be great.
Thank you.
And if it'd be helpful, I can send along some materials that might be useful there.
Yeah, if you have them, please share them with Jeff. That'd be great.
And we have a history of doing this kind of study, not this one particular, but it was the athletic survey that we did across the district, put it in the strategic plan, and then executed on it. And that has been very effective. And it hasn't been that things haven't slipped for a year before. Those decisions have been made based on what's going on. The pandemic played part of that. But so this isn't a new rodeo. It's just a new version of the rodeo that we did a few years ago. So we can look back on that, and if anyone has any questions, we can kind of go back through how that was done and see how effective it was at planning. Again, you're making guesses when you're going 5-10 years out, especially when you see what inflation's doing right now. So it's a very thoughtful way of doing it, but it's not an exact science. But I think the way that we did it the last time was incredibly effective, and we can see the results of that. What we've done at the stadium, what we've done with the Ram Cage, those are just starters of what's been done. You can look around the district and see not only has it been done effectively, but the number of students that it's impacted. When we look at how many students this is going to affect, this is everybody in our district. This is every student, this is every staff member. So again, appreciate the efforts, and I think we can have confidence moving forward once all the recommendations and data comes in that we've got the best information. All right, we'll move into the next item, which is recognition of visitors. Is there anyone who would like to speak regarding?
We do not have anybody who's signed up.
Okay. We will adjourn as a board to executive session.